Okay. Good morning, my student. Uh, Welcome back to the physics session for this day. Okay. So today we are going to continue with what we have studied in the last week about the electrostatic. So last week we have studied the formation of the atom and what are the constituents of the atom. Okay. And we have studied, in addition to that, the difference between insulators and conductors, and what is the difference, what make any material is good conductor to electricity, and what makes any material is a bad conductor to electricity. Okay, and we have seen that a material can be described as a good conductor to electricity um, when it has some kind of free electrons moving in the outermost shell. And a material can be described as a not good conductor, or as a bad conductor to electricity when it has no free electron to transfer. Okay, so the conductor or insulators is mainly depend on the kind of electrons in the outermost shell. Okay, so if you have a free electrons, okay, means you have mostly you have a good conductor to electricity. If you don't have a free electrons, or if you have some confined electrons, means this might be a bad conductor to electricity. Okay, so today we are going to continue with what we have studied. Okay, we said that the basic law of electricity is that we have two kinds of charges inside the atom. We have protons, we have electrons, and um, opposite charges are attracting each other, and the same charge or um, same charges are repelling each other. So this is what we have studied up to this moment. Okay, and today we are going to talk about, the first thing we are going to talk about is induced charges. So what we mean by induced charges? If you remember from the experiment that I have shown to you in the last video in the last week, that if you have, for example, if you have a pen and this pen is a charged, okay, or just try just to produce some kind of charges at the surface of the pen, and you are going to attract some uh, piece of papers, okay, piece of papers. So the papers will be attracted toward the bin. Why that? Because actually at this moment the bin will have, or the parts of the bin will have a positive charge, and the papers at this moment will have a negative charge, and they will kind of polarization. So what do you mean by polarization? Polarization means you have in one side, for example, if this is a pen here, this is a pen, and the pen here has a positive charge. Okay, so in the other surface you have a negative charge. Okay, so this is polarization. What do you mean by polarization? Polarization is some kind of, you have different kind of charges and they are going to be attracted to each other. So this is what we mean by polarization. So polarization is about attraction. Okay, attraction. And when you have different kind of charges, okay, they are going to be polarized to each other. Means polarized, they are going to form two poles. Okay, one of them is positive pole and the other is negative pole. Okay, we call this a polarization. Polarization means you have kind of different charges and they are trying to do some kind of attraction or repulsion on each other. So this is what we call it as um, kind of polarization. Okay, so this is something we can do with neutral object. For example, if you have something, I'm going to charge it. Okay, this thing, for example, this pen at this moment has no kind of a charge. Okay, but I'm going to just try to induce some kind of a charge. So means I'm going to try to rub this kind of pen with any kind of a charge to have a charge. Okay, I'm inducing, I'm just trying to bring some charges to the pen. Okay, and this moment a positive charge will be created at the surface of the pen. Okay, what about the other surface? The other surface will behave in the other way. So it will act as a negative charge. And some kind of attraction will happen between the pen and the paper. And this kind of polarization, we call it induced charge. So actually, the pen itself has no charge. Okay, it has nothing. Like it's a neutral. In the beginning, the pen is neutral because it's made from plastic, and plastic don't conduct electricity. But by just trying to conduct some electricity for a very very small time, okay, by just trying to um, rub this pen with any surface that have any kind of charges, it might create it, so it might create some kind of charges at the surface of the pen, and the difference between the charges in the pen will create what we call it as um, charges. Okay, so the difference in charges will create polarization. So polarization is known as the difference of charges. Okay, so this is one of the basic application for electricity. For example, you have a very like you have a um, some neutral part, and you are going to induce this part with some kind of charges. Okay, so at this moment the induced charges will be accumulated at the surface of the bin, at the surface of anything. So you will have some different kind of charges. Okay, and a polarization phenomena will happen. Why polarization phenomena will happen? Because you have different charges at the different surface. So means you have here negative charge and you have here positive charge. And between those two kind of charges, two different kind of charges, polarization will happen. So this will form a positive polar, and the other will form a negative polar. Okay, and this is what we call as a polarization. One of them, each one of them will form uh, a polar. Okay, it will form a pole. Okay, so the next thing we are going to talk about is this related to the same thing but in different way. Okay, so it's about lightning. Okay, and lightning is something you can see here, the same as we said before. Okay, you can see here in the upper part you have a positive charge accumulated, and in the negative, in the lower part you have a negative charge accumulated. So this is what we mean by polar. Okay, means the upper part form a positive pole. Okay, and the lower part form a negative pole, and between them there is kind of induced charge. So you are trying, you are encouraging the upper part to take a positive pole, and you are encouraging the lower part to take a negative ball, so a negative charge or a negative ball. So this is induced. You are just trying to create two kind of balls separated from each other. Okay, so this is the basic phenomena of induced charges. Okay, you are trying to make two different kind of charges by inducing them. Means you have actually you have nothing charged in reality. Okay, but you are trying to make them to interact as a positive charge or a negative charge. So this is the basic thing you are going to do. Okay, you are going to just create a charge for every part, for the upper part and for the lower part, okay? Okay, lightning is something a very, very interesting phenomena. We may have seen this kind of phenomena before, okay? But what will happen in the lightning, okay? In the lightning, for example, imagine that the air molecules, okay? So the air molecules are not charged, they are neutral, okay? But what will happen when you have a lightning in the sky, okay? The particle of the air will be charged, will be uh, polarized, okay, into a positive and negative pole. And this is why lightning is a is something related to electricity. Why? Because in the lightning you can find that some particles will have a positive charge and other particles will have a negative charge, and this what create electricity, and this is what create light that you can see with your eyes in the sky, because some particles in the space will take a positive charge, others will take a negative charge. So this is what we call electricity. This is what will bring electricity. So imagine this is a lightning phenomenon, okay? And you have here, um, this is air molecules, okay? So the air molecules will start to be polarized. How? Some of these particles, some some of the air particles will take the positive charge like that, and the others will take a negative charges like that, okay? So the difference between them will produce a positive polar and negative pole, okay? So this what creates electricity. Electricity can be created by the negative in charges, okay? So you have different kinds of charges. Marwan, close your, everybody, close your cam. Okay, so this what creates the poles or the difference or the polarization in the lightning. Why? Because you have the air molecules is not polarized, and when lightning is happening, some kind of polarization will happen to the air molecule. So some of the air molecules will have a positive charge, the others will have a negative charges, and this will create a difference in the ball between them. So they will be polarized and they will create electricity. So for this reason, why we can see some kind of light in the sky, because electricity at this moment is created. Why electricity is created? Because air is become to be polarized. Polarized by any means or by any way, by that just dividing the air molecules into positive and negative charges. Okay, so some of them will have a positive charge, others will have a negative charges, and the difference in the in the kind of charges that every particle will have from the others will create electricity. So this is the basic phenomena of electricity. This is why electricity happening during the light. Okay. Okay, another thing we have to talk about when we talk about static electricity or electrostatics is one of the most important application for this is to prevent explosions. Okay, so imagine you have, for example, airplanes. Okay, and the airplane is provided with tires. With this tires is has a um, no charges. So this might create some kind of electricity. This might create some kind of explosion. So for this reason, we are trying to manufacture or just trying to make the tires with some kind of a charges, because it become polarized, it become um, charged in the when it start to move in the air. Okay, so this is something can prevent the explosion in the air. Okay, so this is something can prevent explosion. So one of the most important application for the electrostatics is to prevent explosions, okay, by having two different potential. It means you have two different um, charges accumulated in the two sides, okay. So this will create a charge transfer, means you have here positive charge in one side, as we said in the induced charges, you have here negative charge, and on the other side you have positive charges. Okay, so this is what we call it as charge, and the charges will start to transfer from this part to the other part, or from this part to the other part. Okay, so this is a charge transfer. Okay. Okay, the next thing we are going to talk about is Van de Graaff. Okay, so Van de Graaff is very, very important because it's a phenomena that we use it to a machine that we use it to create electricity. Okay, so Van de Graaff is something I'm using to create um, charges. Okay, so actually it's a device that we use it every day to create charges. So how it's working? It works by this. We have you have a belt here. This belt is divided into two sides like that. One of them will have a positive charge and the other will have a negative charge, and the charges will start to transfer along the belt. The belt is stretched by two things, so the charges will transfer from this part here, moving down, and then the charges in the other side is going to move up. So this will create a a stream of charges, okay, moving from one part to another. Okay, so you have in the beginning you have a source of charges. Okay, so you have electric field or magnetic field that create charges, and the charges will start to move down, and then charge another charges in the other side will start to move up, and this will create some kind of difference in the charges, and it will create, in addition to that, a stream of charges. So why I'm using Van de Graaff? Van de Graaff is used to create some kind of charges. Okay, so you have, and in the one side you have negative charges like here, and you have in the other side positive charges, and this kind of charges, this kind of high stream of charges is created all the time. Okay, since you already have a source of a charge. Okay, so you have electric field, you have magnetic field, and these things can create a charge. Okay, so the charges will be accumulated at the two surfaces, and the stream will be operating all the time. So in the one side you will have a positive charge, the other side will have a negative charges, and the kind of transfer or the kind of movement of the charges between the two parts will be continuous. Okay, so means you have positive charge transfer from this part to the other part of the belt, and so on. So this movement will continue for a very, very long time. Okay, so the basic function for this application or for this device, Van de Graaff, is to create different kinds of charges. Okay, to create different kinds of charges and the stream of charges happening all the time. Okay, so another thing we have just to talk about is digital sensors. Okay, so digital sensors is something that we using um, many times. For example, think about your mobile phone. Okay, mobile phone or laptop is made of many small parts, okay, many small chips. We call these chips as capacitors, okay. So capacitors basically is something that we use it to store charges, for store charge, okay. So the basic function for capacitors is to create or to store charges, okay. And capacitor is something that it depends on electricity, and it's a very functional and very small parts that, like, you have in every mobile phone, you have many of them, many of capacitors working together just to create like they create electricity to the very small devices like this. So capacitors is example of digital sensors, or it's a very small parts that create electricity, and it stores electricity, store charges inside a very small part. So you have no, like, you don't have any kind of think about the very big batteries, okay, we are using to store electricity. You can do this, but with a very small thing like digital sensors, okay. So a very the best example to explain the idea of digital sensors is by capacitors. Capacitors, as I told you, is something we use it to store a charge, okay. So you have, and the one side here, if you have a capacitor, you will have induced the charges, like positive charge in the upper side and negative charges in the other side, okay. And there is some kind of um, difference. There is some kind of electric field between them, and depends on the distance between them. So by this way, you are going to store some kind of a charges inside the capacitor itself, okay. So this is a way that this capacitor or digital sensor is working, by creating some kind of induced charges between two different sides, and this kind of charges will be accumulated, and um, it depends on many things, depends on many factors, like the electric field between the two sides, the length between the two sides. All of these factors will govern, will control the functionality of the capacitor and the benefit of this capacitor, okay. So this is the basic phenomena, this is the basic explanation for capacitors, okay. And as I told you, digital sensors is very important. It's become vital for our life, because think about millions of devices that we are using, that all of them depends on some kind of this very small chips. We are trying to include it inside our devices, like mobile phone, like screen, like LCD or LED. All of these devices are depending on capacitors, okay. In the very old days, we were using a very old thing, we call it cathode ray tube. But now, thanks to the development in technology, we are using a modern apparatus to just try to store energy, to store electricity inside our devices. And one of the most important example of this kind of uh, devices is capacitors. And the idea of capacitors, as I told you, this is a device that we use it to store electricity inside, okay. So um, if you have any questions regarding this part, please raise your hands. Mariam? Mariam?
Um,
Yes.
does polarization occur in capacitors?
Yes, there is accumulation of charges at the two sides of capacitors. Okay, so in the upper part you will have a positive charge, and in the lower part you will have a negative charges. And there will be electric field created between the two sides. And in addition to that, it will depend on also on the distance between the two sides. So this is the two important factors that will control the behavior of capacitors. Okay, how many electricity this capacitor can store inside. Okay, so this is just about, but the basic idea about capacitors or digital sensors, Mariam, is it's something we are using to create, to store, to produce electricity in a very, very small chips. Think about, like, think instead of just having a very, very big device, you have a small thing, okay, and you can create a high amount of electricity inside this. So this is the basic idea of sensors or capacitors. And as I told you, like you have here positive charges in one side and the negative charges in the other side. And if you have understood the idea of induced charges, this is the same way, okay? This is the same way. You have one part, but here you have actually have a charge, okay? The two sides are charged, okay? I'm not trying to create any kind of like creating a charges from by rubbing something or do something like that, but actually the two sides are charged, but there is some kind of polarization happening between them. Okay, Rawan?
Mister, I did not understand the part about induced charges.
Okay, Rawan. So induce the charges again, okay? So you have, for example, you have, think like if you have a bin, if you have like a bin here, and this bin is made from any plastic or anything like that, okay? And and so this bin is basically is not a charge, okay? It has no kind of a charge, okay? Any kind of charge can't be created at the surface of the bin. But I'm going to just try to um, uh, bring any kind of a charges to this bin. How I can do this? By trying to scratch this with any kind of source of charges, okay? For example, if you have a silk surface, just try to scratch this bin with the surface you have. So the bin at this moment will have any kind of a charge. So we'll start to create a charge. Okay. So, but before that, the bin has no, it has no kind any kind of a charge. So there is no any kind of charges at the surface of the bin. But after that, a kind of charges will be created at the surface of the bin. Okay. So you will have here a positive charge, for example. Positive charges um, will be accumulated at the surface of the bin. And you have a beaver, okay? So the beaver has no charges too, but when you try to to just attract or make the bin is close to the beaver will start to be attracted to the bin. Why? Because at this moment, another kind of charges will be accumulated at the surface of the paper, and this kind of charges will be negative. So there's some kind of attraction, as we said in the last time, between the positive charge here at the surface of the bin and the negative charges on the paper. So this is what we call as induced charges. Means you have kind of charges, and this kind of charges will start to interact. However, in the beginning, both of them has no charges. Okay, both of them have no charges. But after that, you started to create a charge in the one part, so the charges will be accumulated at the surface of the other part. So there will be a difference in the charges, okay, between them. So this is the basic understanding for induced charges. You are trying to create a charge from nothing. Actually, you have no charges in the bin. you have no charges in the paper. But when the pen is acquire any kind of charges, this kind of charges will be interact with the paper. So the paper at this moment will start to create its own charges. So so the entire system, the pen and the paper at this moment will have their own charges. Okay, so at this moment they will have their own charges. The pen will have, for example, positive charge. The paper will have a negative charge, and this will create some kind of induced charging between them. Okay. Who else has any question? If you have any questions, raise your hand. Okay.
The Van de Graaff generator was invented by Robert Van de Graaff around 1930. Used originally to charge particles in atomic accelerators, nowadays it's used mostly to educate students about electrostatics. It can even make your hair stand on end in a dramatic display of static electricity. We'll see how it works. The instrument features a small motor that makes a roller at the bottom of the machine start turning. That roller causes a belt to turn, which then causes a second roller at the top of the machine to turn. Two metal combs are positioned very close to the belt, one at the top, one at the bottom, and the whole thing is topped off by a large metal sphere. Although all Van de Graaff generators have these parts, they're not all made of the same materials and may The Van de Graaff generator was invented by Robert Van de Graaff around 1930. Used originally to charge particles in atomic accelerators, nowadays it's used mostly to educate students about electrostatics. It can even make your hair stand on end in a dramatic display of static electricity. We'll see here how it works. The instrument features a small motor that makes a roller at the bottom of the machine start turning. That roller causes a belt to turn, which then causes a second roller at the top of the machine to turn. Two metal combs are positioned very close to the belt, one at the top, one at the bottom, and the whole thing is topped off by a large metal sphere. Although all Van de Graaff generators have these parts, they're not all made of the same materials and may work a little differently, but they all exploit the relative tendency of materials to lose or hold on to negatively charged electrons. In our generator, the belt is made of cotton, a relatively neutral material. The lower roller is made of Teflon, more likely to attract electrons. When the lower roller starts moving, it rubs against the belt, setting it in motion while creating friction between these two parts. The friction causes electrons to jump from the cotton to the roller, which becomes negatively charged. The belt is left with a positive charge. This exchange of charges is called the triboelectric effect. Meanwhile, something else is going on in the metal comb positioned just under the roller. Metal is a great conductor of electricity, meaning electrons move very easily through it. Because like charges repel each other, the large amount of electrons that have built up in the roller repel electrons away from the tips of the metal comb, leaving those comb tips with a positive charge. Now there is an electric field in the air between the positive comb tips and the negative roller. As a result, electrons in the nearby air molecules break away from those molecules and go to the positive comb tips. They leave behind positively charged molecules, or ions, which are then attracted to the negatively charged roller. The positive air ions can't reach the roller, however, because the belt is in the way. Instead, they end up coating the outer surface of the belt and are carried up to the top of the machine. The top roller is made of aluminum, which tends to lose electrons. As the positively charged belt rubs against it, electrons move from the aluminum to the belt, giving the roller a positive charge. This positively charged roller attracts electrons to the tips of the comb, creating another electric field that, once again, strips electrons from the air molecules that are inside it, but this time toward the positive roller. The positive air ions left behind are attracted to the negative comb tips. Because the top comb is attached to the metal sphere, these positive charges travel toward the sphere and spread out across it. They will accumulate on the sphere until an object, such as this grounded wand, comes close enough to discharge it. Then, as long as the rollers keep rolling, the cycle will begin once again.
Okay,